The National Electrical Code, or NEC, requires a ground wire in all electrical circuits. This includes those running to detached buildings. The ground wire provides a low-resistance path for fault current to return to the electrical panel. This is for protecting equipment and personnel from electrical shock. Voltage drop can be a significant issue when running long distances of cable. A 100 amp feeder running 175 feet will experience a significant voltage drop if not properly sized. To correctly wire a 100 amp feeder to a workshop that is 175 feet from the main panel, the following is required. Firstly, 2 hot wires, secondly, 1 neutral wire, and thirdly, 1 ground wire. The ground wire must be connected to a grounding electrode at the workshop. Examples of grounding electrodes are 2 ground rods driven into the earth. Running a 100 amp feeder without a ground wire is unsafe and does not meet code requirements. It is essential to run a ground wire and check for voltage drop to ensure a safe and reliable electrical connection. When installing electrical wiring, it is important to adhere to the National Electrical Code, or NEC, for safety and compliance. The NEC mandates specific requirements for grounding and voltage drop, particularly when running feeders to detached buildings such as workshops. Grounding ensures a low-resistance path for fault current, protecting equipment and personnel. Voltage drop must be considered to maintain proper voltage levels at the workshop. The correct wiring method involves using 2 hot wires, 1 neutral wire, and a dedicated ground wire. The ground wire must be connected to a grounding electrode system at the workshop, typically consisting of 2 ground rods. Neglecting the ground wire is unsafe and violates code requirements. Always prioritize safety by following the NEC guidelines for grounding and voltage drop. Here's a more detailed explanation of the importance of each component. Firstly, the 2 hot wires carry the electrical current from the main panel to the workshop. These wires are typically insulated and color-coded, often black and red, to distinguish them. Secondly, the neutral wire provides a return path for the current, completing the circuit. It is usually white or gray in color. Thirdly, the ground wire serves as a safety measure, providing a low-resistance path for fault current to flow back to the main panel. This helps to trip the circuit breaker and prevent electrical shock. Ground rods are metal rods driven into the earth to provide a connection to the earth ground. They are typically made of copper or copper-clad steel. Voltage drop is the reduction in voltage that occurs as electricity travels through a wire. It is caused by the resistance of the wire. Excessive voltage drop can cause equipment to malfunction or overheat. To minimize voltage drop, it is important to use the correct size wire for the distance and current load. In addition to the above, the NEC provides specific guidelines for grounding electrode systems. These guidelines specify the size and type of grounding conductors, as well as the installation requirements for ground rods. It is essential to consult the NEC for detailed information on grounding requirements. Furthermore, voltage drop calculations are necessary to ensure that the voltage at the workshop is within acceptable limits. The NEC provides formulas and tables for calculating voltage drop based on wire size, distance, and current load. It is recommended to use a voltage drop calculator to accurately determine the required wire size. In summary, running a feeder to a workshop requires careful attention to grounding and voltage drop. Following the NEC guidelines and using the correct wiring methods will ensure a safe and reliable electrical connection. Always consult with a qualified electrician for assistance with electrical installation. The NEC is a comprehensive set of standards, so consulting the specific articles relevant to your installation is crucial. For example, Article 250 covers grounding and bonding, providing detailed requirements for grounding electrode systems, grounding conductors, and equipment grounding. Article 310 addresses conductors for general wiring, including ampacity and voltage drop considerations. Article 225 covers outside branch circuits and feeders, providing guidance on wiring methods, clearances, and grounding requirements for feeders running to detached buildings. For grounding electrode systems, the NEC specifies the types of electrodes that are permitted, such as ground rods, ground rings, metal underground water pipes, and concrete encased electrodes. The NEC also specifies the minimum size and installation requirements for these electrodes. For example, ground rods must be at least 8 feet long and driven into the earth until at least 8 feet of the rod is in contact with the soil. The NEC also requires that ground rods be spaced at least 6 feet apart. The grounding conductor, which connects the grounding electrode system to the electrical panel, must be sized according to the size of the feeder conductors. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the feeder conductors. Equipment grounding conductors are used to connect the metal enclosures of electrical equipment to the grounding system. This helps to prevent electrical shock by providing a lower impedance path for fault current to flow back to the source. The NEC requires that equipment grounding conductors be sized according to the size of the circuit conductors. Voltage drop is an important consideration when running feeders, as excessive voltage drop can cause equipment to malfunction or overheat. The NEC recommends that voltage drop on feeders not exceed 3%. To calculate voltage drop, you need to know the length of the feeder, the current load, and the resistance of the conductors. The NEC provides tables that list the resistance of different sizes and types of conductors. Once you have calculated the voltage drop, you can determine whether it is within acceptable limits. If the voltage drop is too high, you will need to increase the size of the conductors. When running feeders to detached buildings, it is important to consider the wiring method. The NEC allows for several different wiring methods, such as underground wiring, overhead wiring, and wiring in conduit. The wiring method you choose will depend on the specific circumstances of your installation. Underground wiring is generally the safest and most aesthetically pleasing option, but it can also be the most expensive. Overhead wiring is less expensive, but it can be more susceptible to damage from weather and falling objects. Wiring in conduit provides good protection for the conductors, but it can be more difficult to install. Regardless of the wiring method you choose, it is important to ensure that the conductors are properly supported and protected from physical damage. The NEC provides specific requirements for supporting and protecting conductors. In addition to the NEC requirements, it is also important to follow any local codes or regulations. Local codes may be more restrictive than the NEC, so it is important to check with your local building department to ensure that you are in compliance. When working with electricity, it is always important to take safety precautions. Always disconnect the power before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. In summary, running a feeder to a workshop requires careful planning and attention to detail. By following the NEC requirements and taking safety precautions, you can ensure a safe and reliable electrical connection. Always consult with a qualified electrician if you have any questions or concerns. Using appropriate size conductors is very important to minimize voltage drop. Table 310.15. B16, formerly Table 310.16, in the NEC provides ampacity ratings for conductors based on their size and insulation type. This table can be used to select the appropriate conductor size for a given load and application. However, it is important to consider voltage drop when selecting conductor sizes for long runs. The longer the run, the larger the conductors will need to be to minimize voltage drop. There are several online voltage drop calculators that can be used to calculate voltage drop for different conductor sizes and lengths. These calculators typically require you to input the load current, conductor length, conductor size, and conductor material. The calculator will then output the voltage drop as a percentage of the source voltage. If the voltage drop is too high, you will need to increase the conductor size or reduce the load current. The NEC also provides guidelines for voltage drop in branch circuits and feeders. The NEC recommends that the voltage drop in a branch circuit not exceed 3% and that the voltage drop in a feeder not exceed 5%. These are recommendations, not requirements, but they are good guidelines to follow to ensure proper performance of electrical equipment. When installing grounding electrodes, it is important to follow the NEC requirements for spacing and depth. Ground rods must be at least 8 feet long and driven into the earth until at least 8 feet of the rod is in contact with the soil. The tops of the ground rods must be at least 6 inches below grade. Ground rods must be spaced at least 6 feet apart. If multiple ground rods are used, they must be bonded together with a copper conductor. The size of the copper conductor must be at least the same size as the grounding electrode conductor. The grounding electrode conductor connects the grounding electrode to the electrical panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides a table that specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The grounding electrode conductor must be run in a continuous length from the grounding electrode to the electrical panel. It must be securely fastened to the building structure. The grounding electrode conductor must be protected from physical damage. If the grounding electrode conductor is run underground, it must be buried at least 18 inches deep. When installing electrical equipment, it is important to ensure that the equipment is properly grounded. The NEC requires that all metal enclosures of electrical equipment be grounded. This is to protect people from electric shock. The equipment grounding conductor connects the metal enclosure of the equipment to the grounding system. The size of the equipment grounding conductor is determined by the size of the circuit conductors. The NEC provides a table that specifies the minimum size of the equipment grounding conductor based on the size of the circuit conductors. The equipment grounding conductor must be run with the circuit conductors. It must be securely fastened to the metal enclosure of the equipment. The equipment grounding conductor must be protected from physical damage. In addition to the NEC requirements, there may be local codes or regulations that apply to electrical installations. It is important to check with your local building department to determine what local codes or regulations apply to your project. It is always best to consult with a qualified electrician before starting any electrical project. An electrician can help you to ensure that your project is safe and meets all applicable codes and regulations. When selecting conductors for a feeder, it is important to consider the ampacity of the conductors. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry. The ampacity of a conductor is determined by the size of the conductor, the insulation type, and the ambient temperature. The NEC provides tables that list the ampacity of different sizes and types of conductors. When selecting conductors for a feeder, you must select conductors that have an ampacity that is equal to or greater than a load current. It is also important to consider the voltage drop when selecting conductors for a feeder. The voltage drop is the reduction in voltage that occurs as current flows through a conductor. The voltage drop is proportional to the length of a conductor, the current flowing through the conductor, and the resistance of the conductor. The NEC recommends that the voltage drop in a feeder not exceed 5%. To calculate the voltage drop in a feeder, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant, which is 12.9 ohms for copper and 21.2 ohms for aluminum. I is the current in amps, D is the one-way distance in feet, and Cm is the circular mils of the conductor. The circular mils of a conductor can be found in the NEC tables. If the calculated voltage drop exceeds 5%, you must increase the size of the conductors. When installing a feeder, it is important to use the correct wiring methods. The NEC provides specific requirements for wiring methods. Some common wiring methods for feeders include: firstly, conduit, secondly, cable, and thirdly, wireways. Conduit is a rigid or flexible metal or plastic tube that is used to protect wires. Cable is a factory assembly of 2 or more insulated conductors. Wireways are metal troughs or channels that are used to support and protect wires. The wiring method that you choose will depend on the specific application. When installing a feeder, it is important to properly support the conductors. The NEC provides specific requirements for supporting conductors. Conductors must be supported at intervals that are close enough to prevent the conductors from sagging. Conductors must be supported in a way that does not damage the conductors. When installing a feeder, it is important to properly terminate the conductors. The NEC provides specific requirements for terminating conductors. Conductors must be terminated in a way that provides a good electrical connection. Conductors must be terminated in a way that prevents the conductors from coming loose. When installing a feeder, it is important to properly ground the system. The NEC provides specific requirements for grounding electrical systems. Grounding helps to protect people from electric shock. Grounding also helps to protect equipment from damage caused by electrical surges. Before starting any electrical work, it is important to disconnect the power. This can be done by turning off the circuit breaker that supplies power to the circuit. It is also important to test the circuit to make sure that the power is off. This can be done using a voltage tester. When working on electrical equipment, it is important to wear appropriate personal protective equipment. This includes safety glasses, gloves, and insulated shoes. It is also important to use insulated tools. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician. An electrician has the training and experience necessary to safely perform electrical work.